The following footage is from a commercial project the Water Research Laboratory undertook in 2007. The project looked at the potential for using managed aquifer recharge to manage stormwater in the area. And as part of the project, WRL installed a number of monitoring piezometers across the site in South Sydney using a subcontracted drill rig. The type of drill rig you use typically depends on the nature of the work, and in this case WRL used a hollow flight auger type rig, and at this particular site a lot of the drilling was beneath a concrete slab. So a cutting tool was connected to the rig initially to cut through the slab to gain access to the soil and sediment below. Once the concrete cutting was completed, the auger drill bit was attached and drilling into the ground commenced. With this particular rig, some of the cuttings are returned to the surface and some stick to the auger. Samples of these cuttings are examined to determine the changes in the sediment with depth. By laying them out, it gives you a good visual of how the sediment profile changes with depth. Incremental lengths of auger are added as the drilling progresses, and drilling continues until the required depth is reached. In this case, the required depth was the bottom of the unconfined aquifer. At this point, the drill rig couldn't progress any further because the sediment became too hard. With this drilling method, a hose is put down the auger to flush out any sediment that might be caught inside the auger. As there is a danger of the hole collapsing, the monitoring piezometer is installed inside the auger once the sediment has been flushed out. The monitoring piezometer consists of a section of PVC with slots in it, called a screen, with a cap on the end. This is inserted into the hole, and then pieces of sealed PVC pipe are screwed into it, collectively called the casing. Sections of casing are continually screwed in until the piezometer reaches the surface. Once that happens, the drill bits are removed around the casing. As the augers are removed, the hole naturally collapses around the casing. A bentonite seal is added just above the screen to stop any vertical flow. For any sections that don't naturally collapse, the cuttings are used to backfill the hole. Just below the surface, the piezometer is cemented in. Some piezometers are cut off above ground level and a protective steel casing put around them. In this case, it is cut off just below ground level. A cover is put on the PVC to ensure nothing foreign gets in, and only water enters into the piezometer through the screen. A steel lid called a gaddick cover is used to cover the piezometer. The gaddick cover, though cemented in, can simply be removed by an Allen key. If the piezometer is installed below the water table, it will already be partially filling with water. Though not shown here, the piezometer is then developed by removing a large quantity of water from it. This ensures that only natural groundwater is sampled, and any drilling muds or other material introduced during the drilling process is removed. The piezometer is now ready to be used for water quality or water level measurements.